Hey everyone, welcome to Coding with Destiny. Today we're going to be talking about data types. Did you know that in C++ we have more than 15 data types? Today we're going to be focusing in each of them, talk about when to use one, and then how to initialize them in C++. So get ready, get your coding boots on, and let's go. Alright, so as you can see from the picture I'm showing on the screen now, it shows a table of different classifications of data type. There is groups of data types in C++. We have the primitive data types, those are like the fundamental data types, and that's what we're going to be focusing on today. The derived data types, those are gotten from the primitive data types. I'm not going to go deep into them today. That's for the next video. And then the user-defined data type, there's a whole other video on its own. If I talk about everything in this video, we're gonna go today. But I will explain what they are, just slightly touch them. So let's start with the primitive data type. So what are the primitive data types? We have the int, used for storing integers, float for storing decimals, double for storing very large decimals, char for storing just a single characters, void is just a pointer to nothing. So direct data type array is just a pointer to data in memory that are stored in just a single line with each other. Let's say we have numbers that are stored in memory one after each other. The first number, when you create an array like that, it will be pointing to the first number in that length, that's that part of the memory. Pointer, just like the name sounds, it points to something in memory. Just it stores the address of a particular data stored in memory. Then functions, I'm not going to go deep into functions. Function is just a block of code that does just one thing, or it can do multiple things, but we should try to keep our function small, just make it do just one thing. It just returns or doesn't return something, or just does something. Then the user-defined data types structure is like in object-oriented languages. Object-oriented programming structure would be like a class or a template for creating objects. So it has other data types as fields within it. Let's say a structure of, let's say, a person might have the name, age, size, and things like that. A Boolean value can only take two values, that is true or false, yes or no, 1 or 0. So it's just a very simple data type. It doesn't complicate things. Then the reference and class, we're going to be talking about those in a different video. Next up is this table shows us the sizes in bits occupied by these data types in memory. So for a char, it occupies 8 bits, that's 1 byte. Used for storing characters like A or just very small numbers. Very small numbers. And then it can take ranges from -127 to 127. Like 8 bit, 2 raised to power 8 is 128, yeah, but it starts from 0. So that's why it's 127 there. Then we have signed and unsigned char. For these, I'm gonna explain using some kind of diagram because it's kind of a hard concept, not really clear. I don't know if, okay, it's not showing. I need to take my pen. I need to take my pen. Let's. All right, so for the signed and unsigned, all right, so for the signed and unsigned integers, what really differentiates them is how they are stored in memory. and how they are like explained, how they are viewed, how they are interpreted. So for we have let's take an example. Let's imagine this is let's use a very simple sign. Let's say it's 1, 2, 3, 4, 5, 6. And add two more there, two more blocks. So this is the like the highest bit. So in signed integers, this highest bit indicates the sign. It doesn't contribute to the size of the number. It only tells the interpreter or the compiler the sign, whether it's positive or negative. So if it's 1, it's a negative number. If it's 0, let me say negative. If it's 0, it's a positive number. So used to set the sign flag in I don't want to go much detail into that kind of concept. But it's not that, yeah, that's the reason why if you look at our, let me bring up my graph again. If you look at our table here, you can see that unsigned char goes from 0 to 225 for these 8 bits, for this same 8 bits, while signed char, the highest it can go is 127, and it also has negative values. But like the difference here is if you add this to give you close to from 0 to this is 256, from 1 minus this to that is to 127 is 256. So the range is still the same, but like the maximum for unsigned numbers is bigger because unsigned numbers start taking values from the biggest bit, and that's like the one that carries the most value. So if you if this is an unsigned number, if this is unsigned, this would be like 1 here, and I think it's like 256 or 255. No, I don't know how what it is actually, but like it is, this one is included in the countings. So this is 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. So if you sum all this, you'll get the value of, okay, all these are 0, so yeah, we don't include them. So this is actually 1 to 8. If it's unsigned, but like if it's signed, this is just 0, because you can't even have minus 0 because this is just 0. So it's supposed to be something like minus 0, but like it will be 0 since minus 0 is same as 0. So from here we can see why signed integer and unsigned integer will have things like, I hope this was clear enough. So this also tells you, from this diagram, you can also see how numbers are stored in diagram. So when I say 8 bits, this is actually what I mean. This stuff here, 1, 2, all of them. The lowest bit can be 0, 1. This one, the maximum is 2, like just binary digit bits. So that's that for that. And then I think that also clears up the part of signed and unsigned int. An integer can be 16 or 32 bits. The maximum for the minimum is minus. As for unsigned, this is for signed, and then for unsigned int, it can go up to 65k. So short is also 16 bits, but it can go up to 32 bits. That's why integer is bigger than a short. And then a long is an integer that is like larger, just a larger integer, just going more. Is whole numbers, but like it's a larger whole number. And then float is for big, storing large decimals. Short is actually storing small decimals, but decimals that can just be contained within 16 bits, while 32 bits sized floats are stored in floats. 32 bit sized decimal values are stored in floats. So let's say you want to store something like the size or the population of the world or the country. That's not even a big enough number. Let's say if you want to store a very large number, just use double or long double. If it's like a decimal or something, or long int if it's like a very large integer number, a very large whole number that you're expecting. Let's say you want to store like trillion, 100,000, billions or something like that. Yeah, this is actually the exact value here. If it exceeds 65k, you know that it can go it can go into an int. If it exceeds 2 billion 100 and that 1 million and this extra stuff here, it can't go longer than an int. It can go it can go into a long int. Then long int, if it goes higher than this value here, then you know that you're in big trouble because our compiler can't contain it. Then that's basically data types in C++. Let me show you some applications in code. So I won't be like in this video, we just talk without showing any code, so it won't be like boring stuff. So you include your libraries, your import library. Let's say IO stream. We can print out stuff, and then our int main. So now I think you understand what we mean by int main. It returns 0. 0 is the whole number. So that's why we're using int, and then it can for it is the smallest type of whole number is int. So we restore it an int. So to get the size of a number, you can do int 5. No, int number is equal to, let's say, 5. Let's say you want to print out the size of this number. You use the function called size of, that is number. That is size of. It takes a number, let's say number. And then you do this, you save. My IntelliSense is just making all this thing look like there are errors on this screen, but yeah, later we'll remove it. You compile, you do g++ minus o, and just run, and then data types.c++. Compile it, and then you run it. Do run.execute, and then yeah, what is outputted here is 4. That's 4 bytes. So an integer is 4 bytes. 4 bytes is 32 bits. So that's correct. If you add something like, let's say, long int, and then you save, you compile, you run, this is still showing us 4 bytes. 4 bytes. Yeah. And that's because from our size table, we can see that a long int is also 32 bits. So that's correct. But if you add another long int, we're expecting something else. We're expecting 64 bits, and that is 5 bytes. Yes, I think, yeah, divided by 8. Let's run it. Oh yeah, that's right, 8 byte. Yeah, 8 and 8, 64, yeah. So the size of long int is 64 bits, and that is 8 bytes. So a byte is 8 bits. So let's try. I don't know if something like exit, but like let's just see. Let me see long. Oh, there's nothing like that. But like let me see if C plus plus can go that long. Oh yeah, there's nothing like that. So we can just start playing with the compiler. Okay guys, so before I go, let me quickly talk about string. I forgot to talk about strings. A string is an array of characters. The length of a string is the size of a string can be gotten by length, like dot length of like the string dot length, or like string dot size. So let's say for a character, let's say age, or let me say first letter or whatever is equal there. People get the size of this character. We do, let's say the fields size of this to give us 1. Compile it. I don't know, it's taking time to compile, but like yeah, compiling. I'll run it. Yeah, you can see on the terminal is 1. But for a string, let's say string is gotten from a standard library. So standard string name is equal to, yeah, use double quotes for string, and then you save it. If you do size of won't actually give you the length of the data that it contains. It will give you the size of the string object. So we're not expecting, I don't know how many characters are there, 7. So we're not expecting 7, we're expecting something larger, because it will give you the string is a class, it's not just a natural data type. So it has some kind of properties like capacity and other things within the class. So it will give you the size of this whole stuff together. If we compile it and run it, and this also varies with implementation in different, I don't know, systems. Like if it's in32, in64, it's will vary based on that. And I think we're expecting 32 or something yeah, for this 32. When you want to get the actual length of the data contained within there, you use dot length or dot size. They do name dot, let me say length. Length of it will give you the length of the size of the actual data that's stored in that string object. Now I'm expecting something like 7 or something like that. Run this. Yeah, 7. I've driven the point down on data type, the sizes, and everything. So if you found this video helpful, like and subscribe, tell your friends about my channel, share my videos. If you have a problem, write it in the comment section. I will always reply your comments. Thanks for watching. See you in another one.